Let's jump right in. We're exploring a seriously fascinating concept today, the idea that social behaviors are just as biologically inevitable as a giraffe's massive heart or a desert rodent's hyper-efficient kidneys. There is a precise evolutionary logic to how animals, and humans for that matter, interact. By the end of this explainer, you're going to see the world of social behavior through a completely new, mathematically driven lens.
Section 1. The Mystery of the Skulls. Okay, let's dive into this with a biological puzzle that perfectly sets up our whole journey.
Imagine you're an evolutionary biologist, and you uncover these two sets of remains. In species A, the male skull is massive compared to the female's. But in species B, the male and female skulls are exactly the same size. How on earth could you look at these simple bones and predict which male is a cheating fighter and which one is a devoted father? It sounds impossible, right? But with the right framework, the answers are actually staring right at you. To solve that skull mystery, we need to acquire the right evolutionary tools. And the absolute master tool is understanding behavioral evolution. This is the concept that there is an inevitable logic to how organisms function and behave. And they are constantly optimizing for one ultimate goal: the transmission of their genes over time. But to truly use this tool, we first have to unlearn a massive misconception.
Section 2, the group selection myth. Before we build our toolkit, we need to completely trash a romanticized myth that nature documentaries have been feeding us for decades.
Picture this classic scene. A massive herd of wildebeest reaches a crocodile-infested river. They're terrified. Then suddenly, an elderly wildebeest pushes to the front and heroically leaps into the jaws of the crocodiles, sacrificing himself so the rest of the herd can safely cross elsewhere. We're always told he did this for the good of the species.
And this brilliantly illustrates one of the worst urban myths of evolution. Actually, scratch that. He isn't sacrificing himself at all. When you look closer, that elderly wildebeest is being violently shoved from behind by a younger, stronger herd. Evolution isn't about the survival of the group, it's about the reproduction of the fittest individual. Literally no one is volunteering to be crocodile lunch for the good of the species.
Section 3. 3 blocks of behavior. So, if animals aren't acting for the good of the group, what exactly is driving them? Let's assemble the 3 fundamental building blocks of animal behavior.
Every single social behavior you observe in nature comes down to a combination of these 3 strategies. Organisms use these specific blocks to optimize passing on their genes. Let's break them down one by one to give you a clear roadmap for our evolutionary toolkit. Block number 1 is individual selection. This is driven by natural selection for survival traits, like speed, and sexual selection for attractive traits. And sexual selection can produce some wild stuff, like giant green paisley antlers, just because the females like them. The rule here is incredibly simple: maximize your own reproduction. As the famous evolutionary saying goes, sometimes a chicken is just an egg's way of making another egg. The behavior is just a selfish vehicle for genes to replicate.
Block number 2 is kin selection. The geneticist J.B.S. Haldane summarized the vicious mathematical logic of relatedness perfectly. I would gladly lay down my life for 2 brothers or 8 cousins. See, you share 50% of your genes with a sibling and about 12.5% with a cousin. So genetically speaking, saving 2 brothers or 8 cousins equals passing on your own genes. Animals literally run this math. Vervet monkeys, for example, keep exact track of kinship lines, instantly looking at a specific mother when her specific infant cries out in the bushes.
The third block is reciprocal altruism. This explains why non-relatives sometimes cooperate. It's the classic "you scratch my back, I'll scratch yours" principle. Many hands make a task light, so cooperation really pays off. But there's a huge catch. If you cooperate, you have to be incredibly vigilant against cheaters who will try to take a free ride without giving anything in return.
Section 4. The game of life. So how does this reciprocal altruism actually work out in the wild when everyone is essentially out for themselves? To understand this, we need to introduce the concept of game theory. Now, what's really interesting about this slide is the famous prisoner's dilemma. If you both cooperate, you get a solid reward. If you both cheat, you both lose. But if you cheat while the other guy cooperates, you win big, and he's left with absolutely nothing. Back in the 1970s, an economist named Robert Axelrod ran massive computer tournaments pitting different behavioral strategies against each other to find the mathematically optimal way to behave.
The winning computer strategy that drove all other selfish strategies straight into extinction was astonishingly simple. It's called tit for tat. You start by being nice and cooperating. If the other player cheats, you immediately retaliate next time,
But, and this is key, if they go back to cooperating, you forgive them immediately. It's clear, it's totally fair, and it's brutally effective at preventing exploitation while still maximizing cooperation.
And we actually see this exact math dictating behavior in the wild. Vampire bats will literally disgorge blood to feed non-related babies in their cave. But if they notice a mother bat hoarding blood and not sharing, they will tit-for-tat her right back and let her babies starve next time. Even tiny stickleback fish will use tit-for-tat logic when approaching a predator, retreating exactly in sync if they think their swimming partner is backing out.
Section 5. Tournament versus pair bonding. Let's move to Sokoa and see how this builds our understanding to finally solve that skull mystery we looked at earlier by applying our brand new behavioral tools.
Nature gives us a stunning dichotomy. On one side, we have tournament species like savanna baboons, where males are huge and aggression is off the charts. On the other side, we have pair bonding species like South American marmosets, where males and females look identical, aggression is super low, males are highly involved parents, and twinning is incredibly common. These perfectly align with the massive skull and the identical skulls we saw at the start.
In the brutal reality of tournament species, a staggering 95% of all reproduction is carried out by just 5% of the males. Females select mates purely for hot genes, muscle, size, big fangs. The males pour absolutely all their energy into fighting and growing huge to win the tournament, meaning their lifespans are short, and they completely abandon the female the second mating is done.
Contrast this with the pair bonding species with the identical skull sizes. Here, females do not want a massive, aggressive fighter. They choose for parental competence. Essentially, they want a male who acts like a female. They want a devoted soccer dad who will stick around and share the immense caloric burden of raising children. This shared duty is exactly why females in these species can afford to have twins constantly.
Section 6. The human confusion. All right, we've looked at baboons and marmosets, but where exactly do we fit into this grand evolutionary framework? This is the ultimate question, isn't it? When we apply this biological puzzle to our own highly confusing society, what are we? Are we built for hyper-aggressive tournaments, or are we biologically destined to be perfectly monogamous, devoted pair bonders?
So the crucial point is that humans are terribly, entirely confused. If you look at our biology, our body size differences, our life expectancies, and our anthropological history, we sit exactly halfway in between the two extremes. Most cultures traditionally allowed polygamy, yet the vast majority of people within those cultures paired off monogamously. We are a profound, messy, evolutionary middle ground.
Which leaves us with this final provocative thought. If our very anatomy and anthropological history leave us hovering right down the middle, caught between being violent tournament fighters and devoted pair bonders, is the endless complexity, infidelity, and drama of human relationships really a failure of morals? Or is it simply the inevitable mathematical logic of a beautifully confused evolutionary design? Definitely something to think about next time you catch yourself acting for the good of the species. Thanks for joining me on this explainer, and I'll catch you next time.